Hello, welcome back. So this is our third lecture regarding stack chapter. So in this lecture, we are going to discuss the implementation of capacity-unbounded stack using an array. Okay, and the example is in the textbook Java stack example 2 stack int. And we have this stack int class, but this time we implement with the capacity unbounded way, okay? But of course, like previously in my lecture, I said it's not possible to make it unlimited. It's just that it can grow and shrink. And so we don't have that constant capacity. Instead, this time we use an instance variable to keep track of the capacity. We call it current capacity, okay? And we initiate to 8, okay? And majority part of this stack int class implementation, it's pretty same as first capacity bounded stack implementation. The only place that we change is a push operation, okay? Because this time, if it reaches the current capacity 8, okay, and we will let the array grow, and we double it to 16. And if it reaches 16, then we double it to 32. Okay, we keep doing like this. So how do we do it? Let's see. So we don't have that exception, okay? We don't throw exception. So over here, okay, if the top already reaches the current capacity, then we double the current capacity by 2, okay? After that, we reassign the elements, okay, from the original array. And this time uh, we specify the range of the array is going to be start from 0 all the way to the most updated capacity. Okay, so that's the only place that's changed for the capacity unbounded array. Okay, and before we move to the main, and in the driver, or what we discussed as the application is, we call it base N conversion. Okay. So let's say, suppose if N is 2, then it's how do we convert an integer to a binary number. And for other base, the same algorithm. Okay, for example, suppose we have 13, okay, and we want to convert it to a binary format. So how do we do that? Yeah, we can use a stack. So the way to do it is we use 13 divided by 2. 13 divided by 2, so the remainder, we do the integer division, okay? So by 2, so it will, the remainder is 1. And for the remainder, you push it to a stack, okay? So this is an integer stack. And then you divide by 2, then you have 6, that the remainder is 1. And then, so 13 by 2 is 6, and the remainder is 1, okay? Then you use this 6 divided by 2 again, so it's 3, and the remainder is 0, okay? And then use this 3 divided by 2, it's 1, and remainder is 1, okay? And 1 divided by 2 and it's 0 and the remainder is 1, is it? So each time for the remainder, you push it to the stack. So 1, 0, and then 1, and then 1. Okay, so you push all of the push a remainder to stack. Okay, after that, then we can get to the binary number. So to get to the binary number, you just pop them up. Okay, so pop first number is 1, and then you pop another 1, and then you pop 0, and then you pop 1. Okay, until it's empty. So now the 13th binary format is 1101. Okay, so that's how we do base and conversion. Okay, so in our example, we can do like base 2, base 8, something like that. Okay, conversion. And let's take a look the driver part. Okay, about this base and conversion. Okay, so what here we do is we do the binary base, hexadecimal, and octadecimal. Okay, so base 6 and base 8 also. Okay, so here we have a method. We call it base n. So calculate a base n, okay, and we return an integer. So this is a number that you want to convert, and this is the base, okay. And we don't support the base greater than 9 or less than 0. So we throw exception. And we need a step. If you recall, I analyze a diagram, okay. So this is the decimal number that you want to convert, okay. And when we do the division, it will keep changing as it. So we name it as a quotient. Okay. So if a quotient is still greater than 0, we have the remainder, push it to the stack, and then you keep do the division. Okay. So that's the first part. You fill the stack. And for what we do for the second part is because we are going to return the result as an integer. So 1101, it's not 1101, okay? But we want to return as an integer, but this is a format. Otherwise, you just output as a string, is it? But here we just want it to return as an integer, so that's why the format is 1000, but it's not. This is binary 13, okay? So what we needed to do is then we needed to know how deep the stack is it? So in this case, it's a full, is it? And we are going to base it using 10. So 10 to the 4, is it? That's the power, okay? And then we are going to get each digit, okay? And each digit, so the first, so 1101, is it? So the first, so last in, first last, so 1, is it? You get it, so that's a digit. And then you times 2 to the power, so get the top is 3, okay? As 10 to the 3, is it? And then you keep adding, is it? And for the next one, then it's 1 times 10 to the 2. And the next one is 0 times 10 to the 1, is it? And the last one is 1 times 10 to the 0, okay? So that's how we get this 1101, okay? Okay, so that's about the base conversion, and it also applies to other base, okay, base 6 and base 8. In our example we showed. Yeah, you can see. Okay, so that's the second example. In our next lecture, we are going to discuss the next topic. See you.